Hi, in this video we are going to implement the depth first search together. So let's get started. I'm going to create a package and I'm going to name it depth first search. It's going to be, okay, don't save. I'm going to create a distinct class for node. Okay, and the class for the DFS algorithm itself, and one class from which we are going to test it. Okay, so as far as the nodes are concerned, I'm going to create a class, and we are going to define a constructor. It's going to get a name as a parameter, so the name is equal to the name, and as we have discussed in the breadth first search video, it's quite the same. It is like capital letters, or for example names of cities, whatever that represents the nodes of our graph. It will have a self-dot adjacency list. Adjacencies list is equals to an empty list. A predecessor, we don't need a predecessor as we have seen earlier, so I'm not going to define it, but we definitely need a visited field. I'm going to set it to false by default. What's the self.visited equals to false? Okay. Sometimes this Eclipse is being strange. Okay, the same, and it accepts it. Okay. As far as the depth first search is concerned, I'm going to define a single method, DFS, representing depth first search, of course. And we are going to implement our algorithm recursively. So we set the node visited, we set it to true. We just print out our node. It's going to be the node.name, and for all the adjacencies, node.adjacencies list, if not n.visited. So if we haven't visited our node yet, we just call this method recursively, and we should use it's quite a common lemma in software engineering and algorithmic programming that whenever we use recursion, we could use a stack data structure as well. So we could implement this problem with the help of stack, but usually I prefer recursive method calls, and it is important that the Java, Python, C++, these programming languages are stack-based programming languages, so the operating systems are going to transform our recursive problem into a stack-based algorithm. So if we implement this problem recursively, in the end it's going to be implemented with the help of a stack. So whatever, I prefer recursive method calls because it's much more compact, and I think if you have a good grasp of recursion, it's very, very easy to read. Okay. I'm going to import from depth first search.node, import node, import DFS. I'm going to create a node 1. It's equals to a new node A. I'm going to create B, C, D, E, C, D, E. I'm going to set the node 1.adjacencies list, adjacencies listed append node 2. I try to simulate the same problem we have seen during the breadth first search. 3, 4, 5, and 2, 3, I think 2, 4. Okay, so we just have to call the DFS, that depth first search, with the node 1. And if you may recall, breadth first search travels the graph layer by layer, but here it's not the case. It's go as deep as it can be. D and E is the deepest node in our graph, because C is the child of A. So it is not on the last layer, and E is on the last layer. So it keeps as deep as it can, and then visit these nodes recursively, and then C will be the last. This is a typical depth first search graph traversing. So that's all. Thanks for watching.